this is Repost again. I want to just welcome you now in our video PDEs again. Please, before we begin our video, please subscribe my channel, please like my videos, please share my videos and click the notification button so that you don't miss another video on Repost lectures. Now today, in our last video, we ended in solving this. We are solving case 3 of the PDE, where P was less than what? 0, and we are read that P is equal to negative lambda squared. This is what we are doing in our case 3. So we solve this equation here and reached here. Now today we are going to now input the boundary conditions. The boundary conditions are only 2. We are going to consider when x is what? 0. That means the whole function is what? 0. So now that's the first boundary condition. The second boundary condition is going to be when x is what? 0. Because when you compare this and that, find out our x is what? 0. It means our x is what? 0. So wherever the x, I'm going to put 0, then the whole function is what? 0. So it's going to be 0, the same as a cos, it's going to be cos of where there's x, I'm going to put what? 0. So cos of 0 is what? 1. So put here 0 becomes what? 1. Because of 0 which is 1. Plus b. B sine of 0 is what? 0. B times sine of 0. Because our x is what? 0. Put here 0, find out it's going to be what? 0. Then you have c e to the power negative lambda squared sigma squared then t. Very important. Now, but this one here is a value. Our c is a value of its own. Our e is a value of its own, so it cannot be equal to 0. So our c being a value of its own can be 0. It's a constant. Then our e to the power negative lambda squared sigma squared t cannot be equal to what? 0, because they are values of their own. But now the term in bracket uses 0 property can be equal to what? 0. This term in bracket is equal to what? 0. Meaning our a times 1 the same as 0. So meaning our a is what? 0. That's very important. So after doing that, we're going to test the second boundary condition when what? X is equal to L. So the second boundary condition says U L of t. So we compare this and that, find that our value of x what? Is L. Same as what? 0. So meaning the whole function is what? 0 when x what? Is L. Because when you compare this and that, you find that our x same as L. So you put there what? Is L here. But now you have to be aware that our value of A is what? 0. Since our value of A is 0, that means the first term will what? Will die. Will be eliminated. This one will be what? 0 times this. So it will be eliminated. So this one will be what? 0 plus B sine lambda x is what? L this time. Then c e to the power negative lambda squared sigma squared t. We get. So now this being a value of its own, this being a value of its own can be equals what? 0. Meaning our c can be equals what? 0. Our exponential negative lambda squared sigma squared t can be equals what? 0. Because they are values of their own. So then next the whole function in bracket can be equals what? To 0. So that means because that's using the 0 property. The word it says a times b same as 0, meaning either a is same as 0 or same as 0. But now this being a value of its own can be equals 0, can be equals 0. But now the term in bracket can be equals what? 0. Meaning our b sine lambda L is same as 0. So next, then also b is a constant. Being a constant, that means b cannot be equals what? To 0. So then I can say sine lambda L is same as 0. But also we know sine can be represented in another form. But you know that sine of any multiple of pi, you get, is same as 0. Meaning sine of any multiple of pi is same as 0, where n can be any value. Can be 1, 2, 3, 4, even 0. So when sine of 2 pi is 0, sine of 3 pi is 0, sine of 4 pi is 0. So that means sine of any multiple of pi is what? 0. That's the condition. So we can substitute here, we can say sine now what? Of lambda L the same as sine of n pi. So therefore, since they're the same, that means lambda L is same as n pi. We get. So what is lambda here? That means lambda is same as n pi over L. That means for any value of n, which is what? 0, 1, 2, 3, and so on. For any value of n, so that's our lambda. So we're getting our lambda, we can pick this lambda and substitute back in our equation, which we had saw in our previous video. So if you don't know how to get this equation, please go back to my previous video and see how it is solved. So let's substitute this one here inside that equation. So that means our u x of t the same as a cos of what? Now our a remember it was 0, so that is a waste of time. It's a waste of time. If you put a there, it will be a waste of time. So our a is 0 from this. If our a is what? 0. That means we're going to b and c only. So it's going to be b c sine of lambda. This lambda here, the value is what? N pi over L. So substitute here. It's going to be N pi over L times what? X. Then our c is already here outside. Then our e is going to be our exponential negative lambda. So our lambda is this N pi over L. So it's going to be negative N squared pi squared over L squared. That is our lambda. Then that symbol sigma squared. Then what? T. C is very important. So that's what I've done. Our a is what? 0. That's why this term that was eliminated. But now, if you compare this to Fourier series, find that we can let them do what? Bn. So just say let BC is same as Bn. Just for simplicity, you're just simplifying the equation using Fourier series. So our u x of t is same as Bn sine of n pi over L x exponential negative n pi, this is squared over L squared sigma squared, then t. Are you following very well? So after reaching this point, we can call this equation equation number 1. This is equation number 1. After applying the boundary conditions. So after applying the boundary condition, so you have found that this case has given us a solution. So after that means it holds for p less than 0. So after that, we're going to apply now the initial condition. Initial condition happens when t is equal to 0. So this is initial condition. Applying initial condition. Why are we putting the initial condition? Because we have got a solution in this case. So that means our u x of 0 is same as 0. Meaning our time is what? 0. Initial condition happens when time t is what? 0. So compare this and then find that our x is x, our t is what? 0. So wherever there is t here, we'll put what? 0. So let's substitute and see. You put here. This one is same as f of x. That's the initial condition. Same as the function. It's a function. When our time is 0, our old function, our u of x of t is same as f of x. So substitute here f of x. I'm substituting for this f of x when t is 0. So that means wherever there's t, I'll put what? A 0. So when you put here 0 where there's t, you find that the whole function will be equal to 0 and it will be eliminated. So that means our function the same as that. That's very important. Yeah. So after that, we can do what we call a linear combination or what? A linear combination of this function here. We can sum it because the values of n are many. There is n equals 0, n equals 1, n equals 2, n equals 3. There are many values, so we can do a linear combination. We can sum the whole what? The whole values. After summing the whole values, we shall see that we are going to have a bigger solution. So if you compare this, you find that this is a Fourier sine series. It's in the form of what? A Fourier sine series. So using a linear combination of this, because we said our n can be equal 0, 1, 2, 3, and so on. So when you sum different values of n, that means our equation what? 1 can be like this. So you can say by linear combination of equation 1. Why we sum? Because we have different values of what? N. That means our u x of t is going to be equal to summation from n equals 1 to infinity of bn sum sine of n pi x over L. Then exponential negative n squared pi squared over L squared sigma squared, then t. So why I'm putting this summation? I'm putting summation because we have various values of what? Of n. Since we have various values of n, that means our equation can be written what? Like that. So after getting that, so our initial conditions are like this. So that means our n, our t was what? Was 0. So now if you can see this, if you can compare this, you find out that our summation of bn from n n equals 1 to infinity sine of n pi x over L exponential negative n squared pi squared sigma squared then t over L squared, the same as our function of what? Of x. So if you compare this, you find that it's a Fourier sine series. Why is it Fourier sine series? Because our an is what? Our an is 0. The term an is what? 0. There's no cosine in this. So this is what we call a Fourier. It's called a Fourier sine series. Why is Fourier sine series? Because our function an is what? Is 0. Since our function an is 0, this is Fourier sine series. So being a Fourier sine series, we can write this Bn using Fourier sine series. So what is Bn for Fourier sine series? So Fourier sine series, you're going to quote from Fourier series. Our Bn is the same as 2 over L integral from 0 to L f of x. So that's our Fourier sine series. It is that times sine of n pi x over L. So that is our Fourier sine series for Bn. So since the integral is respect to what? To x. So this is our Bn for a Fourier sine series. So this is since our Bn, we can put this Bn and substitute back in our equation, we shall get our solution. So we can substitute back in this equation. Of course, maybe equation what? From number 2. So substituting this equation 3, substitute equation 3 in 2. While quoting this, you are quoting it from Fourier series. Bn is same as that for Fourier series. So you can pick this and place it where inside there. That means our u x of t the same as summation from n equals 1 to infinity. So what's our Bn? Our Bn is this. So substituting back here. So that means you shall have 2 over L integral from 0 to L f of x sine of n pi x over L dx. That's our Bn. Then you put this remaining term here. So you can put it times the remaining term, which is what? Sine n pi x over L exponential negative n squared pi squared over L squared sigma squared then t. So this is our solution to the PDE. So what does it mean? That means for p less than 0, it what? It satisfies. It satisfies the what? It satisfies the boundary. That's a conclusion. The boundary and initial conditions. So since it satisfies, that means it is a solution to a PDE. That means this is our solution to the PDE because our condition for p less than 0, it has satisfied the boundary and initial conditions. So this is our last video on what PDE is. So please follow the series from the first video up the last video. It is just a continuation. Please follow it and you'll enjoy it because it's simple to understand. Please like my videos, please subscribe to my channel, please repost lectures and share videos to your loved ones and click the notification button so that you don't miss any video post lectures. Yeah, thank you.